Hello, welcome to my channel. In the last video of game theory, we discussed 2 into 2 games without saddle point, that is Oddments method. So this was the first method which we will be using to solve a mixed strategy game theory problem. Now let us today take up the second method, that is dominance property method. So under dominance property method, we will be solving two problems here. Dominance property method can be used for fixed strategy as well as for the pure strategy. So pure strategy is a problem where we have a saddle point. So by using dominance property method, we can find out the saddle point, and this method can also be used for mixed strategy problem. So first let us take up mixed strategy problem here. Now, what is the rule to follow dominance property method? See, dominance property method says that the payoff matrix which has been given in the problem can be reduced. ಅಂದರೆ payoff matrixನ ಸೈಜನ್ನು ನಾವು ರೆಡ್ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಹೇಗೆ ರೆಡ್ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಬೈ ಎಲಿಮಿನೇಟಿಂಗ್ ದಿ ರೋಸ್ ಆರ್ ಕಾಲಮ್ಸ್ ಆಫ್ ದಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ರೋಸ್ ಆದರೂ ಎಲಿಮಿನೇಟ್ ಮಾಡ್ಬೋದು, ಕಾಲಮ್ಸ್ ಆದರೂ ಎಲಿಮಿನೇಟ್ ಮಾಡಿ ನಾವು ಈ ಸೊಲ್ಯೂಷನಿಗೆ ಬರ್ತೀವಿ. ಸೊ ಸೊಲ್ಯೂಷನ್ ಈಸ್ ದಿ ಆಪ್ಟಿಮಲ್ ಸ್ಟ್ರಾಟಜಿ ಬೈ ದಿ ಪ್ಲೇಯರ್ಸ್. ಸೊ ಹೌ ಆರ್ ವಿ ಡೂಯಿಂಗ್ ಹಿಯರ್? ಕೊಟ್ಟಿರೋ ಪೇ ಆಫ್ ಮ್ಯಾಟ್ರಿಕ್ಸನ್ನೇ ನಾವು ರೆಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಬೈ ಎಲಿಮಿನೇಟಿಂಗ್ ದಿ ರೋಸ್ ಆರ್ ಕಾಲಮ್ಸ್. Now first we need to understand what are the rules to eliminate rows and columns. Let us first come to rule for row elimination. So row elimination ಹೇಗಾಗತ್ತೆ ಅಂತಂದರೆ, one particular row in a elements, ಎಲ್ಲ elements. So if all the elements in a row is lesser than or equal to. ಸೊ ಒಂದು ರೋಯಿನ ಪರ್ಟಿಕ್ಯುಲರ್ ರೋಯಿನ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗಳು ಇನ್ನೊಂದು ರೋಯಿನ ಎಲಿಮೆಂಟ್ಸ್ಗಳಿಂದ ಸ್ಮಾಲ್ ಇತ್ತು ಅಂತಂದರೆ, ಲೆಸ್ಸರ್ ಇತ್ತು ಅಥವಾ ಈಕ್ವಲ್ ಇದ್ರೂ ನಡೆಯುತ್ತೆ, ಅಂಥ ರೋವನ್ನು ನಾವು ಎಲಿಮಿನೇಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಇಲ್ಲಿ ನೆನಪಿಟ್ಕೊಳ್ಳೋದೇನು, ಒಂದು ರೋಯಿನ ಎಲಿಮೆಂಟ್ಸ್ ಮಿಕ್ಕಿದ್ದು ರೋ ಎಲಿಮೆಂಟ್ಸ್ಗಿಂತನೂ ಚಿಕ್ಕದಾಗಿರಬೇಕು, ಸ್ಮಾಲ್ ಆಗಿರಬೇಕು, ಲೆಸ್ಸರ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಗಿರಬೇಕು, ವ್ಯಾಲ್ಯೂಸ್ ಕಮ್ಮಿ ಇರಬೇಕು. ನೋಡಿ, ಇಲ್ಲಿ ಬಾಕಿ ಎಲ್ಲ ರೋಸ್ಗಿಂತನೂ ಅದು ಕಮ್ಮಿ ಇರಬೇಕು ಅಂತ ಏನಿಲ್ಲ. ಒಂದು ರೋಯಿಂದ ಅದೇನಾದರೂ ಎಲಿಮೆಂಟ್ಸ್ಗಳು ಕಮ್ಮಿ ವ್ಯಾಲ್ಯೂದಿತ್ತು ಅಂತಂದ್ರೂ ನಾವು ಆ ರೋವನ್ನು ಎಲಿಮಿನೇಟ್ ಮಾಡ್ಬೋದು. ಈಗ ಇದೇ ನಾವು ಕಾಲಮ್ಸಲ್ಲಿ ಹೇಗೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನು ನೋಡೋಣ. ಸೊ ಕಾಲಮ್ಸ್ ಇಲ್ಲಿ ರಿವರ್ಸ್ ಆಗುತ್ತೆ, ಮ್ಯಾಕ್ಸಿಮೈಸೇಷನನ್ನು ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಈಗ ಯಾವ ರೋಯಿನ ಎಲಿಮೆಂಟ್ಸ್ ಬೇರೆ ರೋಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇದೆಯೋ, ವ್ಯಾಲ್ಯೂಸ್ ಜಾಸ್ತಿ ಇದೆಯೋ, ಆ ಜಾಸ್ತಿ ಇರುವಂಥ ಕಾಲಮನ್ನು ನಾವು ಎಲಿಮಿನೇಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ all the elements in a column is higher than or equal to the elements in another column, then the column with the higher elements is to be eliminated. So for rows, lesser value row, for column it is higher value row which we have to eliminate. So ಈಗ ಇದನ್ನೇ ನಾವು ಒಂದು ಪ್ರಾಬ್ಲಮಲ್ಲಿ ಯೂಸ್ ಮಾಡಿ ನೋಡೋಣ how we can arrive at the optimal strategy. So this is the problem here. The following table represents the payoff matrix with respect to player A. Solve it optimally using dominance property. So we can see here that player B is having 4 strategies and player A is having 4 strategies. So both the players are having equal number of strategies. So now how are we going to achieve the optimal strategy by using dominance property ಅನ್ನೋದನ್ನು ಇಲ್ಲಿ ನೋಡೋಣ. So let us begin here. So this is the problem. So where the elements have been given 3, 5, 4, 2, 5, 6, 2, 4, 2, 1, 4, 0, 3, 3, 5, 2. Now to eliminate this, first we have to go row wise and the second step is column wise. ಇದು ಎಲ್ಲಿವರೆಗೂ ರಿಪೀಟ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ, ನಮಗೆ ಒಂದು ಸ್ಯಾಡಲ್ ಪಾಯಿಂಟ್ ಆದರೂ ಸಿಕ್ಕಿರಬೇಕು ಅಥವಾ 2 into 2 ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆದರೂ ಸಿಕ್ಕಿರಬೇಕು. ಆ ಲೆವೆಲ್ವರೆಗೂ ನಾವು ಎಲಿಮಿನೇಷನ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ ಇದನ್ನು ನೋಡೋಣ ಹೇಗೆ ಎಲಿಮಿನೇಟ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನು. ಸೊ ಫಸ್ಟ್ ಪ್ಲೇಯರ್ ಬಿ ಈಸ್ ಹ್ಯಾವಿಂಗ್ 4 ಸ್ಟ್ರಾಟಜೀಸ್. ಸೊ 3, 5, 4, 2, then 5, 6, 2, 4, 2, 1, 4, 0, 3, 3, 5, 2. So these are the values given in the problem matrix. So this we are going to take it here, and this is player A. 1, 2, 3, 4. So both the players are having 4 strategies here. Now first, to eliminate row, we need to take row total. See, we are going to take the total of the row. 3 plus 5, 8, 8 plus 4, 12, 12 plus 2, 14. Same ways we will do for all the rows. 5 plus 6 plus 2 plus 4, 16. 2 plus 1 plus 4 plus 0 is 7. 3 plus 3 plus 5 plus 2 is 13. Now to eliminate the row, first check which is the lowest value. So 7 is the lowest value here. So 7 being the lowest value, first we will see whether we can eliminate this row. Now let us check each of the element and compare it with the other rows. ಇಲ್ಲಿ ಇರುವಂಥ ಎಲಿಮೆಂಟ್ಸ್ ಯಾವುದಾದ್ರೂ ಒಂದು ರೋಕ್ಕಿಂತನೂ ಕಮ್ಮಿ ಇತ್ತು ಅಂತಂದ್ರೂ ಈ ರೋವನ್ನು ನಾವು ಎಲಿಮಿನೇಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ. ಸೊ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಇಸ್ 0. ಯು ಕಂಪೇರ್ 0 ವಿತ್ ದಿಸ್ ರೋ. ಈ ಯಾವುದಾದ್ರೂ ರೋ ಇಂದ ಕಂಪೇರ್ ಮಾಡ್ಕೋಬೋದು. ಐ ಆಮ್ ಬಿಗಿನಿಂಗ್ ವಿತ್ ದಿಸ್ ರೋ. ಸೊ 0 ಈಸ್ ಲೆಸರ್ ದೆನ್ 2. ಓಕೆ. 4 ಈಸ್ ಲೆಸರ್ ದೆನ್ 5. ಓಕೆ. 1 ಈಸ್ ಲೆಸರ್ ದೆನ್ 3. ಓಕೆ. 2 ಈಸ್ ಲೆಸರ್ ದೆನ್ 3. ಸೊ ಇಲ್ಲಿ ಇರುವಂಥ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗಳು ಈ ರೋ ಅಲ್ಲಿ ಇರುವ ಎಲಿಮೆಂಟ್ಸ್ಗಿಂತ ಕಮ್ಮಿ ವ್ಯಾಲ್ಯೂದಿದೆ. ಹಾಗಾಗಿ ಈ ರೋ ಅನ್ನು ನಾವು ಎಲಿಮಿನೇಟ್ ಮಾಡಬಹುದು. ಓಕೆ. ನಾವು ನೆಕ್ಸ್ಟ್ ಟೋಟಲ್ ನೋಡಿ ಯಾವುದು ಕಮ್ಮಿ ಇದೆ. ಇಟ್ ಈಸ್ 13. ನಾವು ಲೆಟ್ ಅಸ್ ಕಂಪೇರ್ ದಿ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ದಿಸ್ ರೋ ವಿತ್ ದಿ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ಅದರ್ ರೋಸ್. ಸೊ ಇಲ್ಲಿ 3, 3, 5, 2 ಇದೆ. ನಾವು ಲೆಟ್ ಮಿ ಟೇಕ್ ದಿಸ್ ರೋ. ಸೊ ಇಲ್ಲಿ ನೋಡಿ 2 is lesser than 4. Okay. 5 is not lesser than 2. So 5 is a greater value than 2. ಹಾಗಾಗಿ ಈ ರೋ ಎಲಿಮಿನೇಟ್ ಆಗಲ್ಲ. Now let us go to the next one. 14. The total is 14. Check the first element 2. 2 is lesser than 4. Okay. Then 2 is we can do another one here. See, when I was comparing this row with here, you can compare this here also. So 2 is equal to 2. 5 is again greater than 4. So that's why this column, this row was not eliminated. Now come to the first row. 2 is lesser than 4. Okay. But 4 is greater than 2. So 4 is greater. It is not less than the other values. Okay. So this row cannot be eliminated on the basis of the second row. But can we compare it to the last row? Let us check. 2 is equal to 2. What is the condition? The values or the element should be lesser or equal. So here it is equal. So this can be done. Next, 4 is lesser than 5. Good. Then 5, and here it is 3. But 5 is greater than 3. Hence, this row cannot be eliminated. We have compared it with the second row as well as the fourth row. This row cannot be eliminated. Now let us check the last row. So first I will compare it with this first row. So 4 is greater than 2. So again this row cannot be eliminated as compared to the first row. Now let us check for the fourth row. Let us compare it with the fourth row. 4 is again greater than 2. So what is the condition? To eliminate rows, the elements should be lesser than the other elements. But here 4 is greater than the other elements. So hence this cannot be eliminated. So by row wise, by the first step, we could eliminate only one row. Now what shall we do? We will rewrite it. Rewrite the remaining. So player B. So player B, all the 4 strategies are remaining because it is the A's strategy which has been cancelled. So row wise, we will be eliminating A's strategies. To eliminate B's strategies, we need to use column wise. Okay. So first, second, fourth. We are not writing the third strategy here because that has been eliminated. Now what are the values? 3, 5, 4, 2, 5, 6, 2, 4, 3, 3, 5, 2. Now these are the elements and strategies which are remaining for both the players. Now we need to eliminate from the point of view of B, that we need to go column wise. So now again let us take column total. So row total is for player A Column total is for player B. Now first let us take the total. So what are the total? 3 plus 5 plus 3 is 11. 5 plus 6 plus 3 is 14. 4 plus 2 plus 5 is again 11. Then 2 plus 4 plus 2 is 8. So these are the total which we are getting by taking the total. Now how to eliminate? For row wise elimination, we first selected the row with the lesser total. For column, we are going to select the column with the highest total. So which one is having the highest total? It is 14. So first we will check the elements of this second column. Now compare the each and every element of the second column with the other columns. So first we will compare it with the first column. Now here it is 5. 5 is greater than 3. Okay, so for here, for eliminating column, element should be greater or equal to. Okay, so 5 is greater. 6 is again greater than 5. 3 is equal. So equal or greater, hence this column can be eliminated. Now, which is the next one? There we have two columns with the same total. You can start with any one. I will be beginning with the first one. So 3, 5, 3. Now compare 3 with the other column values. If it is greater, then we can eliminate it. So first 3 I am comparing with the third column. So here the value is 4. So this is lesser than the other element. Hence we cannot cancel or eliminate this column by referring to the third column. Now let us check with reference to the fourth column. 3 and 2. So 3 is greater. Here it is 4 and here it is 5. So 5 is greater. The last element, here it is 3, but the fourth column value is 2. So what is happening here? All the three elements are greater than the first column. So we can eliminate this column with reference to the fourth column. Okay, now let us proceed further. Now next is 11. Now check the values. 4 is greater than 2, but 2 is not greater than 4. So hence this cannot be eliminated. Now let us check the last one. 8. So here it is 2. 2 is lesser than 4. Hence this column cannot be eliminated. So we have eliminated 2 columns and 2 rows are remaining. Now again we will repeat the process by again going for the row elimination. So for row elimination, we will write again player B. Now how many strategies are remaining? Only 2, that is third strategy and fourth strategy. Then 1, 2, 4 of player A. So values 4, 2, 2, 4, 5 and 2. Now we will take the row total. Row total 4 plus 2 is 6. 2 plus 4 is again 6. 5 plus 2 is 7. So now begin with the row with the lower total. So we have 2 such rows, 6 and 6. You can begin with any one. I will be beginning with the first one. So let us begin with the 6. Now check these values. These values should be lesser than the other row values. So first 4, compare it to 2. So 2 is lesser than 4 and hence this row cannot be eliminated because there should be lower elements for elimination. So 4 is higher value than 2. So this row cannot be eliminated based upon the second row. Now compare these values with the third row. 4 is lesser than 5. 2 is equal to 2. Hence we can eliminate this row. Okay, so 2, 4, 5, 2. Now next compare the values of the second rows with the third row. 4 is greater. Then 2 is lesser but 4 is greater. Hence this row cannot be eliminated. Now check 7th. The row of the total is 7. So first element 2 is lesser than 4. Okay, this is fulfilling the condition. Here it is 5 and here it is 2. Hence this condition is not being fulfilled because 5 is greater than 2. So this is the thing which we are remained with. So now we are having player B 2 strategies. Player A is also having now 2 strategies, 2, 4. Let's see whether we can further eliminate the columns. So if the columns can be eliminated, then we can reach the optimal strategy. So now column total 2 plus 5, 7, 4 plus 2, 6. Now column maximization. So which one is having the higher total? That is 7. So now check the values of this column. The value should be higher or equal to the values in the another column. So here it is 2, here it is 4. So the value is less. Instead of equal or being higher, it is less. Hence this column cannot be eliminated. Now let us check this. 4 is greater than 2, okay, but 2 is lesser than 5, hence this cannot be eliminated further. So this is the maximum elimination that we can do. So from 4 into 4 matrix, we have reduced it to 2 into 2 matrix. So once we reach this stage, we will be using oddments method. So in the last video, we have discussed how to solve the problem using oddments method. Now that method will be used here. So now let us rewrite it. Player B 3, 4, then player A 2 and 4, 2, 4, 5, 2. These are the values which we are remain with. Now let us go for oddments. Row wise oddments, column wise oddments. So row wise oddments, how we are doing? Okay, we will take the difference of these two values and write the difference in the opposite, that is the next row. So which is the greater value? 4. 4 minus 2 is 2. So we will write it here. Next 5 minus 2 is 3. We will be writing it here. These are row oddments. Now let us go for the column oddments. So here we have taken the values row wise. Now we will be taking the values column wise. So greater value is 5. 5 minus 2 is 3. 3 is written here. Then 4 minus 2, 2, it is written here. Okay. Now probability. This is probability for player A and probability for player B. Okay, so how to find out the probability? Take the oddment of first row, that is 3, divided by the total of the oddments, 3 plus 2, this will be 3 by 5. Next, for second strategy, the oddment is 2 divided by total, that is 3 plus 2, 2 by 5. Okay, so this is the probability of player A. Now player B probability we will see. The oddment for the first column is 2. So here P1, P2, the probability of player A is represented by P1, P2. Same way player B, it is Q1, Q2. So Q1 will be 2 divided by the total of the oddments, 2 plus 3, that is 2 by 5. Q2 oddment is 3. 3 divided by the total of the oddments, 2 plus 3, that is 3 by 5. We have got the probability of both the players. Now let us find out the value of the game. Value of the game is equal to, we will be using the first column values with their corresponding oddments. 2 into 3 plus 5 into 2 divided by the total of the oddments, 3 plus 2. So what will be the answer? 2 into 3 is 6, 5 into 2 is 10, 3 plus 2 is 5. So answer is 16 by 5. So this is the value of the game. Now let us write the optimal strategies for the players. Optimal strategy of player A is P1, P2. Okay. So how many originally strategies were there for player A? It is 4 strategies. You can see it in the problem. 4 strategies, 1, 2, 3, 4. Now we will write these. Let us see the strategies which remained at the end, that is 2 and 4. It means first and third strategy will not be used by player A. So first strategy 0. Second strategy P1, that is 3 by 5. Third strategy is again not used, 0. Fourth strategy P2, that is 2 by 5. This is the strategy used by player A. Now optimal strategy of player B. So player B ಯಾವ strategy na use ಮಾಡ್ತಾನೆ, that is Q1, Q2. Even he originally had 4 alternatives, but the alternatives which remained at the end were 3 and 4. It means that first and second strategy will not be used by player B. So first strategy 0, second strategy 0, Q1 we got the answer 2 by 5, then Q2 3 by 5. So this is the optimal strategy, and value of the game, to summarize, value of the game is 16 by 5. So this is how we are using the dominance method to solve it. See, sometimes it so happens that the entire columns and rows get cancelled and we will arrive at a single value, that is the saddle point. So it means that dominance property or dominance method can be used even for pure strategy. So let us see how to use it for pure strategy problem also. We can eliminate it. See, from the following payoff matrix, find the optimal strategies of the players using dominance method. So here the strategy is having saddle point. If we try the simple method, there is a saddle point, but let us solve it without using the simple method, but let us solve it by dominance method and see how we can do it. So what is the first step? The first step is take the row total. Okay, so row total. So what is the row total? 4 plus 6, 10, 10 plus 5, 15, 15 plus 10, 25, 25 plus 6, 31. So likewise 7 plus 8 plus 5 plus 9 plus 10 will give us 39. Then the row total of the third will be 47. And the last one 10 plus 10 plus 10, 30. Now which one is the least here? It is 30. Let us compare the values of this row with the other rows. So first I will compare the fourth row's values with the third rows. Okay, 6 is lesser than 8, 4 is lesser than 9, 10 is lesser than 11, 6 is lesser than 10, 4 is lesser than 9. Hence the condition is fulfilled. We can eliminate this row. Now next total is 31, which is least. So 31, let us check. So here I will compare it with the second one. You can compare it with third and then come to the second one, no problem. Okay, so 4 is lesser than 7, 6 is lesser than 8, 5 is equal. Okay, no problem, because the value should be equal or lesser. Then 10 is greater. So instead of being less, it is greater than the other row element. Hence, we cannot cancel this row compared to the second row. But can we cancel it compared to the third row? Let us see. So 4 is lesser than 8, 6 is lesser than 9, 5 is lesser than 11, 10 is equal to 10, 6 is lesser than 9. Hence, the condition is fulfilled. We can cancel this row. Now let us further check. Let's take 39. Let's check the values. 7 is lesser than 8, but 8 is lesser than 9, 5 is lesser than 11, 9 is lesser than 10. But here the last element 10 is greater than 9. Hence we cannot eliminate third row. So as there are only 2 rows remaining, we can see that even this row will not be eliminated, because we can just verify it. 8 is greater. We want lesser than values. So only here it is lesser, rest all are greater values. Hence only 2 rows could be eliminated. Now second step, column elimination. For column elimination we need to take column totals. So 1, 2, 3, 4, 5. Now player A, 2 strategies have been cancelled. So there are only 2 remaining, 2 second and third. Values are 7, 8, 5, 9, 10. 8, 9, 11, 10, 9. Now let us take column total. So column total 7 plus 8, 15, 8 plus 9, 17, 5 plus 11, 16, 9 plus 10, 19, 10 plus 9, 19. Now here we have to take the total which is having highest total as compared to other columns total. So 19, there are 2 such columns, you can take any one. So let me start with this last one. Now what is the criteria? The values or the elements should be greater than the elements in the other column. So first let me check with the fourth column. 10 is greater than 9, but 9 is lesser than 10. Hence we cannot cancel this or eliminate this column compared to the fourth one. Can we eliminate it compared to the third one? Let us check out. So 10 is greater than 5, but 9 is lesser than 11. So we cannot. Compare it to the second one. 10 is greater than 8, 9 is equal to. Okay, so then we can cancel. Okay. Then next 19 again. Compare it again. 9 is greater than 5, but 10 is lesser than 11. Okay, now compare it with the second row. 9 is greater than 8, 10 is greater than 9. So it is fulfilling the condition, we can cancel it. Next, take this, the third values, that is 17, because it is having greater total. 8 and 9. Compare these elements with the other column elements. 8 is greater than 5, but 9 is lesser than 11. Hence we cannot cancel it with respect to the third column. Compare it with the first column. 8 is greater than 7, 9 is greater than 8. So we can cancel this. Now next is 16. Compare it with the first column. 5 is lesser than 7. Though 11 is greater than 8, we cannot cancel this. Now check last one. Again we cannot cancel because one element here it is greater, but one element it is less. But we will verify. 7 is greater than 5, but 8 is lesser than 11. Hence we cannot eliminate further. Now we have the final matrix, that is 2 by 2 matrix. Player B is remained with 2 strategy, that is strategy 1 and 3. And player A is remaining with 2 strategies 2 and 3, the values being 7, 8, 3, 11. Okay, our goal is to see that we achieve at the either saddle point or 2 by 2 matrix. Now let us again go for the row total, because we will check after column elimination whether we can further eliminate rows. So row total 7 plus 3, okay, here it is 5. So the values is 5 here. So 7 plus 5, 12. 8 plus 11, 19. Now which one is the lesser value? 12. So first compare the values of this row with the other. 5 is lesser than 11, 7 is lesser than 8, hence we can cancel this. Now we cannot further cancel, so we will go for column elimination again. So player B remained with 2 strategies, while player A is remained with only 1 strategy, that is third one. 8, 11. Now column total, the same will come because there is only 1 row remaining. So column total 8 and 11. So 11 is the maximum value. Check whether the elements in this is greater than the other elements. So it is 11. 11 is greater than 8. Hence we can cancel. Now what is the value remaining? It is only 1. That is player B has to use first strategy and player A has to use third strategy to get or reach the saddle point 8. So what is the optimum strategy? Optimum strategy for player A or of player A, it will be now See, originally player A had 4 strategies. At the end, it is remained with only third strategy. It means that it will not be using first, second and fourth. So how we will write it? First strategy 0, second strategy 0, third strategy it is going to use, so 1, fourth strategy 0. Next, optimum strategy of player B. Player B has to use first strategy in order to meet this saddle point. Even player B had more than one, that is it had 5 strategies. So it will be using, player B will be using only first strategy. So 1, then rest 4 strategies will be 0. Now where is the position of the saddle point? Saddle point position is will be A3, B1. Okay, so this A3 third strategy, B1 first strategy, and saddle point position A3, B1. And what is the value of the game? Value of the game is equal to the value which is there at the saddle point position, that is 8. Value of the game is 8. So dominance method can be used even for pure strategy and mixed strategy. Okay, so out of the 3 strategies we have discussed ornaments method and dominance property method. So in the next video, let us take up the last method, that is graphical method. So please subscribe, like and comment to my channel. Thank you.